So we are ready to talk about digestion functions. I really like this picture. You can really see just how much occurs just from eating a slice of pizza, just what is happening inside the body in order to absorb the nutrients and rid of the waste. And that's exactly what occurs during digestion. It's a way for your body to absorb and use all of the nutrients that is being eaten, but of course getting rid of things that is not needed by the body. That would be the waste, of course. So just as a review of the structures, you have salivary glands that are in your mouth. You have the parotid, which is the large one in your cheek. The sublingual is right below the tongue, and the submandibular is in the jaw area. So it's like the lowest of them all. They secrete amylase, which is an enzyme that breaks down carbohydrates into the monomer of simple sugars. We'll learn more about that next week. But that is all about chemical digestion because you have an enzyme. At the same time, you have your teeth, which is making mechanical digestion, and the food goes down the esophagus due to peristalsis. We'll get into that in a second. So the food's traveling down into the stomach. So this is your stomach. Your stomach has a lot of digestion occurring. That's the first time that you will, well, not the first time, the second time, because you already have amylase up here, but this will be the first time that protein is digested. So this is where your protein will be digested by pepsin. You have your liver and your gallbladder. They work together. So your liver is making bile, and it's being held in the gallbladder until you need it, and it'll secrete it into the stomach. You also have your pancreas. It's another accessory organ that has pancreatic juices, which will help create a more basic environment, and also has enzymes in it. That's going to be secreted into the duodenum. So here's your duodenum of the small intestines. So you go from the stomach into the small intestines. And in the duodenum of your small intestines, you're going to have the rest of chemical digestion occur. All of your macromolecules will be digested here. So you'll have your fats will be digested, all the rest of your proteins, your sugars, and your nucleic acids. And then now that you're in the duodenum, now you'll be in your jejunum. So now you really have some absorption occurring in the ileum as well. So now you're going to absorb the nutrients that are needed. After you're done with the small intestines, the food will keep moving into the large intestines. So let me show you a better picture here. So you can actually see the ileum going into the cecum. You also have the appendix here. So the cecum, once it's in the cecum, now you have a little bit more absorption occurring, but mostly it's just going to make it into the solid that that will be your fecal matter. You also have gut bacteria that's in here, but I'll talk about that later. So you have ascending colon, transverse colon, descending colon, the sigmoid colon, and then you have the rectum, which is about here, and then you have the anus, and then the fecal matter would exit the body. Okay, so let's review the digestive processes. You have mechanical digestion. This occurs with your teeth and also in the stomach. It's where it's physically prepared. In other words, you're going to basically use force to break food down. Chemical digestion is where your enzymes are located. So your enzymes are in the mouth, secreted by your salivary glands. That's amylase. It's also, you have enzymes in the stomach and in the small intestines, the duodenum. Absorption occurs mostly in the small intestines and large intestines. And then you have propulsion. This is going to move once you swallow. Propulsion is happening all the way. So the inside of all of your structures, you have smooth muscle, and it contracts and relaxes to push the food along the way until it's fecal matter and ends up out of the body. Here's a nice diagram I gave you guys. You can see the only thing I would add is chemical digestion. For some reason, they didn't put it in the mouth because, as you know, amylase is secreted, so therefore that's chemical digestion. Okay, so we're going to start in the mouth. So the mouth to esophagus, you have that mechanical breakdown due to chewing. And chewing, as the fancy schmancy word for that, is mastication. So you have mastication occurring. You're chewing the food to mechanically break it down so that you're not choking and it doesn't hurt as you swallow. The start of chemical breakdown also occurs. So you also have chemical breakdown here because you have the enzyme amylase. digesting carbohydrates into smaller glucose. So this is a great example of macromolecules. So you have the carbohydrate macromolecule, you see your bonds, and what happens, your amylase will break. That's what all your enzymes are doing. They're breaking the bonds to make them into smaller pieces, so it's easier absorbed when it gets into the small intestines. It can just absorb right into the walls and be used, in this case, to make your ATP. So now you're in the pharynx and esophagus. So deglutition or swallowing is stimulated by receptors. So as soon as it gets to a certain region in your mouth, you're just going to swallow. Muscles of the pharynx will contract, forcing the food into the esophagus. Internal, you have this thing called mucosa, and it just provides the lubrication needed for food to have an easy passageway. Food is moved from a wave-like contraction called peristalsis. So let's explain what that is. Peristalsis, basically once the food goes through, the smooth muscle will contract, and it will contract in a way to push it all the way down. So as it's contracting, the food, I should say the mush, right, because you already mechanically broke it down, will start to move all the way down until it gets into the stomach. I like to think of like a toothpaste tube, like if you had toothpaste at the bottom and you're pushing it up and you're squeezing, it's similar to what it would look like on the inside. Okay, so now we're in the stomach. What's really interesting about the stomach and what's interesting about your body is your digestion actually begins, you're already starting to get the body into the parasympathetic system just by seeing food. So by seeing it, by tasting it, the thought of it, and what's interesting is corporations actually use this to their advantage. When they make a commercial, they make it very appetizing, so it causes you to be hungry. So you're watching it, and you're like, wow, I'm hungry, and because your body and your mind is already, your acetylcholine is already being sent to the stomach to activate digestion. So your olfactory receptors in your taste buds are relayed to the medulla oblongata to indirectly transmit through the vagus nerve to the parasympathetic system. Acetylcholine is a neurotransmitter that initiates digestion. So your digestion is being initiated. If you've ever driven by somewhere and you're like, I don't know, you either see a sign that you want pizza, I don't know, or you smell it. So like when the restaurant is cooking food and it smells really good and your stomach growls, that's due to the cephalic reflex. Depression or mood can inhibit or excite. So some people, they call them emotional eaters. So when they're going through something tough, they eat more. And then some people, they are opposite. Like they just have if they're not feeling good or they're depressed, they won't have an appetite. It just depends on the genetics in the person. So just showing you when you see food, how it kicks you right into the cephalic phase due to the vagus. Okay, so now that the parasympathetic is underway, these gastric juices called the hydrochloric acid will be secreted by stomach glands. So these exocrine glands because it's exiting that area, is going to secrete gastric juices, and it's very acidic, hydrochloric acid. The presence of the food, so this won't occur yet until the food hits it. So the food is going to hit, so as soon as the food hits the stomach, and the fact that gastric juices and the pH is down, and I know I forgot to write this in, but the pH is between 1 and 3. So once the pH is very low due to hydrochloric acid, and the food has hit that region, you're going to secrete a hormone called gastrin. Very, very important that you know what this hormone is. You're going to have this as a question on your quiz and on your unit exam. That hormone and the fact that you have hydrochloric acid is going to then activate pepsin to be secreted. So pepsin is a protein enzyme. Pepsin will be broken out. So pepsin is a protein. It'll take whatever proteins you have and it'll break it down into smaller amino acids. So that way it can be absorbed into the walls once you get into the small intestines a lot easier. So if you had a steak or beans or whatever type of protein that you have, once you have that, it will break down into smaller pieces there. So what is important to know here, make sure you know that the hormone is called gastrin and the only enzyme is pepsin. Because you have an enzyme, that means that we are also occurring chemical digestion. At the same time, you also have mechanical digestion. So you have 3 layers. You have a longitudinal muscle, a circular, and an oblique muscle. And just imagine these turning in different directions. So one may be going horizontal, one is vertical, and one might be slanted. And as it's doing that, you have that you're compressing and you're pummeling the food and turning it into something called chyme. Once the food is well mixed, peristalsis will begin, and now you're done with the stomach, right? So now that you have broken down your protein and now the food no longer looks the way it did when you ate it, it now looks like chyme. It's going to, this pylorus right here, it's called a pylorus, is like a little sphincter, so it's a muscle that holds it in. It will open up a little bit at a time, and a little bit of food at a time will go into your duodenum. So now we're in the small intestine, so a little bit at a time. Inside of your small intestines, you have something called a microvilli, and those are like little cells that have the enzyme amylase inside. So you have this enzyme amylase, and again, it's taking whatever sugars didn't get broken down in the mouth, it will finish it here. Also, protein digestion will occur in this area also. So that's one of the first things that's going to happen. So chyme will enter the small intestines, and as soon as it hits the small intestines, we have two new hormones, secretin and cholecystokinin. So again, you have two hormones, secretin and cholecystokinin. These two hormones will be released by the walls of the small intestines. And now what's going to happen is you're going to be getting these juices from the pancreas and the liver. So the liver will now start to secrete the enzymes and everything that you need. Your pancreatic juice will be ducted in from the pancreas, and the bile comes from the liver. And inside of there, you have amylase, which is your starch. Starch is just another word for carbohydrates. Enzyme, pepsin, which is your protein digesting enzyme, lipase, which was all your fat digesting enzymes, and nucleic acid. It's a little bit more complex with nucleic acid, so just know that that's also being broken down there. So basically, once you have secretin and cholecystokinin, those, and what triggers it is just food hitting the walls. It's just like it's a reaction. These will be secreted, and now all the enzymes will start to break anything down. So anything that was that large, so anything that was a polymer will now be broken down into smaller units called a monomer, which we'll learn more about that next Monday. At the same time, your pancreatic juice also has bicarbonate, and if any of you guys know, if you're in chemistry, that's very basic. So it's going to neutralize the acidic chyme. So you don't want your chyme to be very acidic. It will burn the walls of your intestine, which is not good. So the bicarbonate, the pancreatic juices, also neutralizes that acidic chyme. Just so you can kind of see what's happening. So you have, this is just the liver, but you can still get an idea. So you have so basically you'd have like the enzymes coming into the duodenum. Once you're in the ileum, pretty much everything is broken down to the smaller parts, because everything was broken down here. And then the smaller, so all of your monomers will now be absorbed into the bloodstream. It'll go to your liver. Your liver will kind of clean everything up, and then it'll go into your stream wherever it needs to go for you to absorb the nutrients. Absorption of water and end products of digestion occurs all the length of the small intestines through intestinal cell membranes, transported in the blood to the liver. And the liver just kind of is like a checking point. Like once it gets in there, it'll check everything, make sure nothing else needs to be cleaned up or sent to the kidneys to be filtered out or whatever. Peristalsis propels food through the tract through small intestines and helps to mix chyme with digestive juices also. I really like this picture. You can see the chyme entering the duodenum, the cholecystokinin and secretin entered the bloodstream, and that will cause all of the bile. And this one actually shows you the pancreatic juices also. So you have your pancreatic juices, which has the bicarbonate ion, which is going to neutralize it, and then you have in your liver. So both of these will also have all your enzymes to break all 4 of your macromolecules down into smaller monomers. Okay, so now we're in your large intestines. Large intestines is pretty easy. So you have gut bacteria that live in the intestinal walls and metabolizes the remaining nutrients and releases your gas. This is where the farts are made, methane and hydrogen sulfide. Gut bacteria is very important. If you don't take a probiotic, I highly suggest it. One sign that you need some sort of probiotic could be if when you're going to the restroom, your fecal matter is very loose. It's not, it's watery, I guess you could say. That means you don't have any gut bacteria. But basically what it does, it produces your vitamin K and some of your B, which is very important. Fecal matter is then delivered to the rectum, and it has the residuals, the mucus, and millions of bacteria and enough water for smooth passage. In your large intestines, mostly it's going to be just getting it out and out of the body. But like I said, the gut bacteria is so important because it also breaks down like cellulose. So like a lot of your plants will get broken down here, and fiber. Fiber feeds this gut bacteria also. Okay, perfect. That's it. And we will review this tomorrow. Have a good afternoon.